Good morning, students. On today's lecture, I'll solve Mathematics Syllabus D, Paper 2, 4024, Variation 21, May-June 2018. In my first question, I have set. It says that use set notation to describe the shaded region in the Venn diagram. Now, I was asked to describe the shaded region. Okay, sometimes it does say describe the non-shaded region, so be careful with that. Now, shaded region doesn't belongs in P and Q. So what I'm gonna do, P union Q, that's the region over here, but I don't want that, so that's the prime of that. You can either do this, or what you can do, you can write down P prime intersecting Q prime. Okay, this looks like De Morgan's law, if you know that. So P prime, or complement of P intersecting complement of Q, that actually means P union Q prime, or whole complement of P union Q. Now, second one, B, universal set is given 1, 2, 3, 4 up to 12, and then X, A is a subset of this universal set, B is another one, C is another one, and there are description of this elements of this set. X is such that X is a factor of 12. It's written in set builder notation. So factor of 12. How can I find out factor of 12? What can I do? I'm going to write down 12 over here. This is the this is the product, and I'm going to find out two factors, that the two numbers that are factors of 12. I'm going to do first 1 times 12. Okay, 1 times 12 is 12. Always any number is divisible by 1, and any number is divisible by itself. So 1 times 12. Next obvious choice I'm gonna do with 2. If it doesn't go with 2, I'm gonna move on to 3. But this time it does. 2 times 6. Then next one, 3 times 4. And the next one, 4 times 3. Now if you look closely, this 3 times 4 and 4 times 3, these two factors are the same over here. So I don't need that. All the factors of A are, so it's gonna be 1, 2, 3, 1, 2, 3, then 4, 6, 12, 4, 6, 12. Okay, these are the factors of 12. Now B is such that X is such that B subset X is such that all the elements of B, X is a multiple of 2 from here. So multiple of 2, I'm just gonna use a different color. So multiple of 2 is gonna be 2, 4, 6, 8, 10, 12. Then I can go 14, 16, 18, but look at this universal set. It's the last digit is 12, so I'm gonna stop right over here. And another subset C, X is such that X is a square number. So what are the square numbers from here on this list? So square number is 1, then I have 4, then I have 9, and next one is 16, but it's not in this range. So that's it. It's better to write down this, then it's going to be very much visible, and you know what to put in here. Okay, because next question obviously going to ask put those values over here, because this is empty. Now show the information on the Venn diagram below. See, okay, now we have to put that first. I'm gonna think what are the elements that are common for A and B. Okay, so A and B, this region I can put it here. Okay, but I have to be careful about this one, because it also belongs to C. Now 1 doesn't belong in B, 2 belongs in B, but look at C region. C is a square number. So is 2 is a square number? No, it's not. So I'm gonna put 2 right over here. Then 3 is not here, 4 is here. Okay, 4 I have in both A and B, but it also in set C, and it's a square number. So that's gonna be over here. Now 6 in both A and B, but it's not a square number. So I'm gonna put 6 over here. Then 8 is not there, 10 is not there, 12 is here, and 12 is not a square number. So I'm gonna put 12 over here. All right, now I'm gonna go for A. Is there any elements that that is common for both A and C? I'm gonna check A and C, because I have done A and B. Now I'm gonna check A and C. Now A and C, 1 is here, and 1 I know it's a square number, so I'm gonna put 1 over here. Now 2 is not here, 3, 4 I already put that, 9 is not there. So I'm pretty much sure about that. Rest of the elements gonna I have to put it in here. So 1 I put there, 2 is here, 3 I didn't, so 3 is gonna be here, 4 already there, 6 already there, 12 is already there. So that's it. Now A is done. I'm gonna go and check if there is any elements common in both B and C. So 4 is there, 4 I already put it, 6, 8, 10, 12, so nothing more. So I'm really happy to see that now I can put these values. 2 is already there, 4 is there, 6 is there, 8 is not, so I'm gonna put 8 here, 10 is not, so 10 is over here, and 12 already there. Okay, now coming to C. Now C, there are only 3 elements, and I saw that already I put 2 elements there. Now 9 is belongs to C, 9 belongs to C, but look at this, it's not a multiple of 2, so it's not gonna be in this region, so I'm gonna put 9 over here. Okay, now I'm gonna go back to my original universal set 1 to 12. If I put all the values, all the elements there or not, 1 is there, 2, 3, 4, I don't see 5, so I'm gonna put 5 somewhere, doesn't matter where. I'm gonna put over here 5. 6 is there, look at this, no 7, so I'm gonna put 7 over here. You can put any region over here, but not inside A, B, or C. 7, so 8 is there, 9 there, 10, 11 is not there, so I'm gonna put 11, and then 12, so it's done. Okay, so this one is done. Now it says that find the number of elements in A intersecting B. Now I know this region belongs to both A and B. They didn't talk about C, so I'm not worried about that. But this particular region, this region over here, I hope you can see that this region where I have 2, 6, 12, and 4 elements. There are 4 elements, and they're asking how many elements are in this region. So I can see 2, 4, 6, 12. So there are 4. All I need to do, write down 4. That's it. Now this one, number 3, it says find number of elements in not in B and C, because B union C prime intersecting A. So this is B and C. Okay, so this, it's not gonna be here and here. So everything this place that intersecting with A. So that's only 3. Okay, so 3 is the element. Now it says how many elements? So it's only 1. Okay, that's that. If you are not having clear idea about that, what can you do? You can write down B union C first. Okay, what is B union C? B union C, all of this, look at this. 1, 2, this is a lengthy process, but sometimes if you are not sure, it's worth it. 1, 2, 4, 6, 8, 9, 10, how many here? In B and C, both B and C, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, I missed 1, 12. Okay, so that's 12. And it says, look at this, it's B union C prime. Okay, so I'm just gonna write down over here to just show you B union C prime, not in these elements. What are the other elements? I'm gonna go there with my universal set. 1 is here, 1, see that 1 is here. Then 2 is here, 3 is not there, so I'm gonna put 3. Now 4 is there, 5 is not here, so 5. Then 6, 7 is not here, 7, 8, 9, 10, 11 is not there, that. Okay, and then I have A. I have all these elements 1, 2, 3, 4, 6, and 12. So A is 1, 2, 3, 4, 6, and 12. And when I intersect that, see A intersecting B union C prime. Okay, then I check that. What are the numbers common for both of them? 1 is not there, 2 is not there, 3 is. So I'm gonna write down 3. Okay, then 4 is not there, so only 1. And it says number. So if I put this number over here, so number over here. So how many numbers are here? 1. So that answer is 1. I hope you can see that. Now one subset in the Venn diagram in part B1, one of the subset has no elements. I can see that this is the place where there is no elements. This is the region. Okay, and use set notation to describe this subset. Okay, so set notation, it definitely belongs both B and C. So I can write down B intersecting C. Okay, this region. But look at this. It doesn't intersect with A. So I can write down, but not in A, whatever the part, then B intersecting C. So intersecting B intersecting C. I hope you can see that. Okay, whatever is B, not A, but whatever I have, B intersecting C. Okay, so that's that. Question number C1, write 540 as the product of its prime factors. So 540, it does look like a multiple of 2 because its last digit is 0. So it's an even number. Even number is always divisible by 2. 2 2s are 4, so carrying 1, I can write down 1 over here. So that makes 14. 2 goes in 14 7 times, then 0. I hope you know how to do this. 2 1s are 2, and 2 goes in 7 3 times, then 1 left, so 10 5s are. Now, test of divisibility. 5 plus 3 is 8, 8 plus 1 is 9. 9 is divisible by 3, so this whole number is divisible by 3. 3 4s are 12, then I have 1, so it's 15. 3 5s are 15. It goes by 3, so 3 1s are 4. Test of divisibility again. 4 plus 5 is 9. 9 is divisible by 3, so 45 is divisible by 3. 3 goes in 4 in 1, then having 1 left, 3 5s are. Now, I don't have enough space, so 15, this 15, I can divide by 3. 5 plus 1 is 6, so it's divisible by that, so it's 5. So what can I do? I can write down 540. I have 2 twice, so 2 to the power 2, and 3 I have 1 2 3, so it's gonna be 3 cubed, and I have 5 ones. Okay, so this is 2 squared times 3 cubed times 5. Product as its prime factor. These are prime factors, and I express this one as its prime factor. Now, P is the smallest possible integer such that 540p is a square number. So let's take 540p. What is 540? It's 2 squared times 3 cubed times 5, then p. So to be square number, I have to have such a value of p so that if I put all of this under the square root, it can get out of there as an integer. Okay, so I have to make all of their power even. This is already even, and square root 2 squared is 2, so this is okay. But over here I need to make power even, so since it's the smallest possible value, the nearest value I need over here for p is going to be 3, because 3 times 3 to the power 3 times 3, that means that's power is 1, and rule of indices is going to be 3 to the power 4. It's an even number. This is odd number, so I need another 5. So 5 to the power 1 times 5 to the power 1 is going to be 5 squared. So p is 15. Okay. Now, it says square root 540p. Now, what was 540? 540 was 2 squared. Then see that this 3 cubed and 3, that's going to be 3 to the power 4, and this 5 and 5 is going to be 5 squared. So when you take the bracket off, that means you are multiplying, it's multiplied, right? So you are multiplying all of them, their power, with half. So when you take the square root off, it's going to be 2 to the power 2 times half times 3 to the power 4 times half times 5 to the power 2 times half. So this 2 cross out, this 2, this becomes 2, this 2 cross out. So it's going to be 2 times 3 square is 9, and this is 5. Okay, 5 2s are 10, 10 times 9 is 90. Okay, so that's 90. So this is 90, but it says that giving your answer as the product of its prime factors. So I need this 2 times 3 square as it is times 5. So I don't need to do this. Okay, so that's my final answer. Okay, now Sammy invests $2,000 in an account paying compound interest. This is compound interest. So this is his principal at a rate. So this is rate per year. Calculate total interest. Okay, but we know compound interest, I have the formula amount. Amount is P, that means 2,000. P is 2,000. then 1 plus r is 1.8 percentage goes as 100, and then time is 3 years. Now I can use my calculator. This is paper 2 calculator version. So 1.8 divided by 100, that's gonna give me 0.018 plus 1, that's that, to the power 3. Okay, so I got 1.05 and bunch of other digits, then times 2000. So I got approximately equal to 2109.96, correct to 2 decimal places. Now we know interest equal to amount minus principal. So it's going to be 2109.96 minus 2000. So minus 2000, I got approximately 109.96. So 109.96. That should be answer into correct answer for 2 decimal places. You can write down 110, okay, to make it 3 significant figures. When you add that, it becomes actually 2 significant figures, but it's better if you write it like that. Okay, nothing wrong with this. Okay, now question B. Teresa takes out a loan. She repays the loan over 1 year at a rate of $54 per month. Okay, so she pays a rate of $54 per month. The total she pays is 8% greater than the value of the original loan. Okay, work out the value of the original loan. I don't know what was the original loan. Let this original loan be, let the original loan be X dollars. Okay, have I taken X anywhere? No. Okay, X dollar. Okay, now see that she pays a loan over 1 year at a $54 per month. So 1 year per month. So total amount she paid 12 months. Each monthly installment was $54. Okay, and she the total she pays is 8% greater than the value of the original loan. So this equal to this value original and 8% of this X. Okay, so I have here, let me have this. I'm not going to multiply that because I can cancel out it later. This is going to be 1x plus this is going to be 0.08x. You can see that 8 divided by 100, that's going to give me 0.08. So that's actually, there is 1, coefficient is 1. So 1x plus 0.08x, that's going to give me 1.08x equal to 12 times 54. Therefore, x equal to 12 times 54 divided by 1.08. And I got $600. Okay, $600. So original loan was $600. That's it. Now we're gonna go for the next one. Question number 3. It says that solve p 4p minus 3 in the bracket equal to 2p plus 7. This is very simple. Take the bracket off. So it's gonna be 4p minus 12 equal to 2p plus 7. Bring this 2p over here and 12 the other side. So bring this 2p over here and 12 to the other side. So 4p minus 2p, it has plus, so this side it becomes minus, and 12 is minus, it's gonna go there and becomes plus 12. So that's gonna be 2p equal to 19. So p is going to be 19 divided by 2. You can keep it in mixed number. That should be 9 to the 18, 9, 1 by 2, or 9.5. I'll keep that in this format. Okay, 9.5. Now, next one, solve this simultaneous equation. Now, I'm going to check that 2x minus y equal to 5, and here 7x plus 2y equal to 1. If I want to cancel out x, I need to multiply the first equation with 7. So the LCM of 2 and 7, they are co-prime, so LCM is going to be 14. So to make it 14, I need to multiply 2 by 7, and I need to multiply 7 by 2. But if I want to cancel out y, then all I have to do, this first element I have to multiply by 2. So this gonna be turn out to be 4x minus 2y equal to 5 to the 10, and I'm gonna keep this one as it is, 7x plus 2y equal to 10. Now if I add that, this is gonna cancel out. It's gonna be 11x equal to 11, so x equal to 1. Now taking that one, 2x's value is 1 from here, okay, minus y equal to 5. Bring this 5 over here. 2 minus 5 equal to y, therefore y equal to minus 3. Okay, so I have x equal to 1, y equal to minus 3. So 3 is done. Question number 4. Simplify. Now question C, simplify this. I can see clearly that from the numerator I can take m common. So it's going to be m plus 3. And below here, I need to do the middle term break. So 2 3s are 6. So I can write down 2m squared plus 6m minus m minus 3. So this is going to be 2m, m plus 3 minus 1, m plus 3. So this is going to be m plus 3, 2m minus 1. So m plus 3, 2m minus 1. This is my rough work. Don't cross it out. You can put it in a bracket. And then this thing gonna cancel out. And I'm gonna having m over 2m minus 1. So my final answer is m by 2m minus 1. Now b is directly proportional to the cube of a. So what the question saying? According to the question, b is directly proportional to cube of a. So when I take this sign off, I'm gonna introduce a constant k, a cubed. Now it says given b equal to 4, when b equal to 4, a equal to 2. So 2 to the power 3. So k is gonna be 4, 2 to the power 3 means 8. So cancel this out. On the top is 1, this is 2. So k is half. Now write down this equation, okay? This equation without k. So therefore b equal to half a cubed. Now I need to find b when a equal to 5. Now b equal to half, a equal to 5. So 5 cubed. That's gonna be 5 cubed means 125 divided by 2. It can be like that, or it can be 62 and a half, or it can be 62.5, or it can be like this. Okay, so I'm gonna write down 62.5. Okay. Now question number 4, it says there are some of the alphabets are given, 12 letters, so there must be 12 letter tiles. Spell the word trigonometry are placed inside a bag. A tile is taken at a random from the bag. Find the probability that the tile shows a letter R. So probability of showing a letter R, give your answer as a fraction in its simplest form. Okay, so how many R are there? You can go here or check it here. There are 1 R and 2 R. So 2 by, there are 12 of them, 12 letters. So 12, you can cross that out. 2 1s are 2, 2 6s are 12. The reason I'm putting 1 on the top, because sometimes when a student cross it out 2 12, they cross it out 6, the answer they write it like that. Okay, so this is a mistake, you know, that the 6 is in the denominator, but the way you wrote down this 6 is in the numerator, that means there is a 1 denominator. Okay, so this is wrong. If you put 1 over here, then you'll remember I have to put 1 over here, so it's 1 by 6, not in below here. That's why I'm doing this. Okay, so the answer is 1 by 6. Now next one, all the tiles are placed back. Okay, so are placed back in the bag. A tile is then taken at a random and placed on the table. The second tile is taken. Okay, so it's non-replaceable. So after taking that, it didn't put it back in the bag. Okay, the second tile is taken at random and place it to the right of the first tile. The third tile is taken and placed. Okay, now find the probability that in the order the tiles were placed on the table, they spell get. Okay, so write down get over here. So first one I'm looking at G, then second one I'm looking at to find out E, then last one 3. Okay, so what is the probability that I'm gonna get first letter G, then and E, then T? G, N, E, and T in this order. So when it's N, then means it's multiplied. This N multiply, this N multiply. So how many G's are there? Okay, so I can see 1 G, nothing more. So it's going to be 1 by 12. Okay, remember it puts over here. So from the total number of tiles, 1 is decreased. So next E, I have only 1 E. So over here, 1 by not 12. Remember, I took 1. So it's going to be 12 minus 1 is 11. Okay. Now, T. How many T's are there? 1, 2. So 2. And then I have taken 2 tiles. 2 tiles. Now I have 10. So I think I have done this. So 2, this is going to be 6. So on the top, I have 1. So 6, 11 is 66 times 10. That's 660. So this is 1 by 660. Okay. So that's it. In my next video, I'll solve from question number 5. Okay. Thank you. Have a good day.